Right, here is my take on how to add wrinkles to like humans like that. And as you see, this is actually, I mean, this looks pretty okay. It looks really sad though. But yeah, it works kinda in the same dynamic way as it used to work with on YouTube with this pipe thing. And the system is pretty much the same, and I just actually created like, I mean, it is not a nice it's not a nice like wrinkle map because it actually is just, it is actually just a wave texture, and I used it just to give the impression it actually looks like kind of something like that. So it's not perfect, but if you would use a perfect map or like a nice high quality map, like I showed you on YouTube, the textures.xyz, then, or it was texturesxyz.com, something like that. You can search, you can find that. Then using these textures, this will give you a really nice result. I'm pretty confident in that. So this is just a random face model I downloaded from, I believe it was like a Turbo Squid or something. I don't know, like it just has to be fixed. Origin to geometry and cursor. No, sorry. Cursor to word origin, selection to cursor, something like that. So it's here, right? And we want to add some wrinkles to it. So how do we do this? As you saw on YouTube, we need two objects and we need the node setup, right? So I could copy the node setup from YouTube, but just in case maybe you had problems, understanding that or something like that, I'm gonna build this from scratch so that you can follow along once more, and I can explain also longer here on Patreon that I could on YouTube. And so I'm gonna add a new set of geometry nodes. This is called the real face, like that. And now we just have to make basically output the gradient from the areas of the faces, right? So how it worked, as you remember, is that you have faces, and for example 4 faces. And now if you contract them, you get something like that. Then the area has become smaller, therefore it has been compressed. Or if for example, they have become something like that, then the area has become bigger compared to this one here. Then it means it is bigger, right? So this area here in the middle will be our base mesh, and this one here will be our real mesh here, real face. So I'm gonna delete all of these. And let's first just output the area of the faces. As you see, we have got quite a lot of those. And also we have some mesh problems here, but I mean, use just a better mesh. This is just for showcase purposes. So what we need first is the face area node, of course. So let's output this to this group output here. And how do we call this? It's up to us. So I can call this, for example, real area. So basically we have the real and the base objects here. I'm going to call this real area, right? And let's preview this, right? So I'm going to output this as it's a float attribute right now. I'm going to open a new shader window here, shader editor. And I'm going to click here. What kind of materials do I have? Blender by default adds this new material up here. So I'm going to click on this, and it should be now on this object, right? And I don't actually have to append this in the geometry node system because I haven't created a new geometry. It is just the same base geometry. So for example, if I now go to the render view, I see this in Eevee, then it's very black, but I'm gonna go up here, I'm gonna drag with the mouse wheel, and I can see here scene world, scene lights. I'm gonna turn these off. So I have this temporary like lighting setup basically. And I'm gonna just decrease the base color so that we can see like the shape of the mesh a little bit better. And we have to actually preview this attribute here. So how do we get this attribute from the geometry nodes side to the shader side here, right? Well, for that we need an attribute node. Attribute, and I'm gonna type in here the name that we output this attribute as the name of this attribute as we output it. It's called real area. So I can just probably cannot copy this. So real area, like that. And let's preview that. It looks like that, very black. That's because the face area is quite small. So if, for example, scale this. Doesn't get any more larger. It still doesn't get larger, which is weird. So maybe let's try like that. Okay. It seems the attribute might not be working. How do we troubleshoot this? I'm just gonna add a math node and I'm gonna just, add something to it. Okay. It seems it's working, right? Because if you do something like that, it seems it's getting output, but it's not just very, very strong. So I'm gonna multiply this with like 1,000. We still don't see anything. Like 10,000. We start to see something. 100,000. Well, it gets white, right? And as you see, we have some could be called like pimples maybe, but these are just unfortunate topology issues because I made this happen with what was it? Instant meshes. It's an application for retopology. So yeah, this looks like that. And what we have to do now is to actually, what we could do is to make this mesh look a little bit better first. So if you can do that, you can remesh this. I'm going to remesh this using maybe, let's just try voxel remeshing. So I'm going to do like a voxel remesh. Where is it? Remesh. And I'm going to put this afterwards like that. We don't have anything here. I wonder if I decrease the voxel size. I'm gonna put like 0.01 here. Well, it seems we have to get like a really small voxel size, and I wonder if it actually is worth the pain, because okay, it seems it's not actually, because it's also open from the like bottom, so it gets really hard to remesh as a voxel. But doesn't matter, our system will work, I think, decently anyways. So this one has been output, and now we want to use this basically to map this to like a blue and red, as you saw. So blue means compression, red means stretching. So how do we do this? Well, first we have to map this to a range, because we map floats, which means floating point numbers, like single, like for example, this one here is a floating point number. But for example, if I have a vector, this one has 3 numbers. It's a vector, it has 3 components. An integer has how many? It has only 1 number. I mean, you cannot have like decimals here, like 0.3 doesn't work. So a floating point number is the area of this face, and we have to get this between 0 and 1, because the color ramp that we can use to apply colors to our values only accepts the range between 0 and 1, right? I mean, otherwise it would be pretty uncomfortable to just like finicky pick something here, or if the range is like, for example, too big, I mean, color ramp would only work on half of the range, for example, or in this case, like 1/3 or something like that. So it makes sense to remap the values. But how do we do this? Well, using a map range, the only one node that we have for that, and it works fine, right? It takes like an output from min from max. So for example, your minimum range and your maximum, and it outputs our very very small range currently to a new range, which will be much larger, right? So it does basically like that, from min, from here, to min, to here, to min, from min is here, and to min is here. From max is here, and to max is up here. So you have to have like the appropriate values between those faces, right? So what is the smallest face area? I don't actually know, and in the YouTube tutorial I used a spreadsheet for that to like manually search for the smallest one, because I was a bit stupid when I recorded this tutorial. I mean, just searching like from this viewer node, like what is the smallest thing here? I cannot even see this properly, like searching like that. This doesn't make sense. So what we are going to use actually is an attribute statistic node. So we're going to take the statistic node, and this outputs some really nice things. For example, the range, like what is the range of those values, what is the maximum, minimum, what is the sum of all the values, what is the middle value from which to the left side there is an equal amount, and to the right side there is an equal amount. That's the mean, I think. So we have a lot of statistics here, and we can plug the attribute into the attribute socket here, like that. I'm going to close this one. And from which geometry? Well, of course, the only geometry we have, which is the face geometry. So now we have things like that. And what is the maximum value? Well, it isn't computed yet because geometry nodes tries to be as efficient as possible, tries to calculate as little things at the same time as possible to keep your computer fast. So we don't have this value right now, but we can connect this minimum to here, and now we have this number. This is a really, really small number, right? It would be really hard to type in manually. I mean, it's power 0, but it's really small. So maximum goes here. And now we have this range here, and this has been multiplied with 100,000, so this makes sense to be very, very bright. So I'm going to delete this one. And now we have this in a normal range, right, like that. And the problem currently is, though, that we cannot leave this like that for a reason, but I'm gonna discuss this reason afterwards. So first, let's map this to like blue and red. So let's make the darkest values blue because they're compressed, and the brightest values red because they are not compressed, they're stretched, and the middle part will be black, like that. Now we have a map like that, which doesn't make too much sense actually, because I mean, these areas here aren't stretched. They would be stretched if I would do something like that, for example. But as you see, right, if I now do something like that, why do all the other colors change? This should only change in the area where I do this, right? Well, the reason behind that, I mean, you see it changes, right? But this should only happen inside the circle here currently and not on the whole face. The reason is because the minimum and maximum values are being dynamically readjusted all the time. So this doesn't work for us. We would like to have like the minimum value of this mesh, but just don't do anything more with it. Just get the value and keep the value around. So let's do so that we actually duplicate this mesh. So we make duplicate, right? This one is the real object, real head. And this one here is the kind of like the memory stick. It keeps the values. We don't change this mesh, but we don't change this mesh, but we will read data and values from it to know what is our, where do we come from, right? This is our reference point. We don't do anything with it, but it's kind of like, you know, just a paper where we write down our values. So, and we can read our values from because they're identical. So anything that is working here will also work on this mesh here. So I'm going to call this base head. So this acts as the basis of our calculations. And now we just have to, I mean, currently they have identical geometry nodes. So from the base head, I'm going to duplicate the system. I'm going to call this base head, and the real head will be called real face. So it's working, right? And now I just have to get the real head, right? And I have to get, I'm going to do so that I'm going to get the min and max from the base head. And when we change the mesh here, right? Well, these values here won't change because we don't change the shape of this mesh here. So I'm going to do so. I'm going to select the real head and I'm going to drag in the base head. I'm going to disconnect this thing here because I don't want to get the statistics, the min and max from this mesh here. I want to get them from this mesh. So I already dragged it into the scene and I'm going to put the geometry here. And now they look exactly the same, right? Because, I mean, with the only difference being that for this base head, we take the values, right, from the underlying geometry. So if I change this, you see we have the same problems. Things are getting brighter, even though I don't want them to get brighter. But here, now if I move this, right, I don't think it gets any more bright because we are actually using the different geometry to get those values from, and we are just projecting those onto this mesh, right? So if I move this, I mean, we don't have any more problems. We just see this thing happening in a very fine manner. But the problem is, I mean, we have colors here, right? So where are they? Actually, the problem is this is a color attribute, but we output this as a float. So just as I did on YouTube, we're going to go to float and select either vector or color. Does anything else work here? Maybe an image also. Let's see the color of the image. It's purple. That's strange. But we are going to use color like that. And for some reason we don't see this anymore. Let's go to the shader editor and let's see what is the problem. For some reason we don't see things. I'm gonna try doing like that. We still don't see things. Ah, I see that. I see why. Because for some reason we have lost the attribute here because it changed the type of it. So I'm gonna type in here again real area, and now we have this thing colored and looking ugly, but it's also working, you know, like that. And now you see the problem right in a more pronounced manner. We are not stretching the nose. She's not sneezing or stuff. It's just a bit wrong because not all the faces have the same area, right? As you see, for example, here the faces have a little bit larger area than they, for example, have here. I mean, here it's pretty small. Here it's pretty large compared to the smallest ones. So what we should do is actually subtract them between like each other. So it means that we just compare if the face areas are different between those two meshes, and we get rid of all those problems and stuff, pretty much. So, how do we do this? Well, we go back to geometry nodes. Well, one of the first things we have to do is, I mean, you see here, it's still black and white. We don't want this. We want this to be output as a color attribute like that. And what else? Well, now we have to subtract those, right? So I want to get this still outputs the real area. This actually has to output the base area, which is used to compare, right? So base area, like that. And now this is black. Why it is black? Why is it black? Well, that's because when you go to shader editor, we are currently previewing the real area attribute, not the base area. So if I would write here base area, this one would turn black and this one would turn colorful again. So exactly like that. So I'm gonna still put here real area because I'm more interested in this one currently. And I'm gonna go back to geometry nodes and I'm gonna get the base area attribute into the real area node tree. So I'm gonna get the base head geometry here, which actually is, I mean, here again, but I'm just making this a bit more tidy. And I'm gonna transfer an attribute from this geometry, which will be a color attribute based on, I mean, it doesn't matter too much, could be index, probably it is the fastest. And I'm gonna try to select the base head base area attribute, but we're gonna select this here. I mean, we don't have an attribute node or stuff. Actually, we can just drag from here. And you're wondering, like, how can we take the attribute of this geometry from this group input? Well, this actually just acts as a literal group input. The only thing that's coming in from this object is the geometry, and actually anything can come in through here. So the attribute is just here. I'm going to call this base area. This is just a name. This can be a dog, cat, base area, cat, whatever. This is just a name for convenience right now. The real name, the imported name, comes in here, right? These are the input attributes. So I'm going to click on this thing here. Now I can, for example, select some anything that I want, actually. And I can write here base area. And now I have to just see if this is working by dragging this to the output. And this looks exactly the same, so it means these are working, right? So I'm gonna drag, this is the real area, this is the base area. They are working pretty nicely. I'm just gonna use a mix RGB and I'm gonna, what is it? I'm gonna subtract, or is it subtract? How should I pronounce this? I'm gonna subtract, well, actually, how it is pronounced? How is it pronounced? I don't know. It doesn't matter. So I'm gonna subtract from this one. So from this one, and plug this to the output. It gets a bit darker, and if I crank the factor all the way up, it gets black, because, I mean, they are the same, so if I subtract, they become 0 because they're identical. Now, if there is difference, I get this map, right? So this is exactly like I had in YouTube with the pipe, and you see there are some like problems, and the problems appear just because of the ugly topology of this mesh, right? It actually isn't a problem of the system or anything. It is just a problem of the mesh, and it actually isn't a huge problem because this, I think, kind of adds some cool variation to this system. So, I mean, nobody cares, I think. And now it's time for some shading work, right? Because usually when making characters, I'm pretty sure they add displacement and stuff in the shading like stage. So how do we do this? Well, currently we have this extremely beautiful black and white, purple or blue and red mask here. We don't want this. We want only the blue channel right now. And if you're wondering why didn't I just output the blue channel, right? Well, maybe I have also a stretch mask. So if I have a stretch mask, I can use the X value from here, like that. I'm gonna show you, like this is the stretch, as you see. And if I have only the compressed mask or the wrinkle mask, I can do something like that. And this only appears where I have this pressure happening. The faces are getting smaller, right? Now, how do we use this? Well, we need actually basically just a wrinkle map first. So I'm gonna do this using wave texture. I'm gonna make this using wave texture. Control T, add some mapping here. I'm gonna rotate this probably by 90 degrees on the z-axis. And also this is the object coordinate system. So if I, for example, now move this thing, I mean, you see, it is not moving with the surface of the skin, so that's a problem. We should use UVs, but currently it doesn't have any UVs. Normal and UVs, right? It doesn't have UVs. So I'm gonna go to edit mode, press A and press U. You could use project from view, but this looks like, well, doesn't give, I mean, not project from view, but smart UV project. And this gives you things like that, which might not be the best thing. I think currently what works is the cylinder projection, like that. It's like more of a better choice for this certain map here. So if I, for example, now go here and I select UV as the vector, it gets probably very big, right? So I'm just gonna do something like that. And if I now take like a piece of the skin and I move this around, then you see it moves with the skin, which is extremely good, I think. I think the right scale is like for about 100, maybe for the head here. And I'm gonna use this as the bump of the skin, right? So color to the height, normal to the normal, and let's see what is happening here. Well, we have something like that because this is obviously too strong. So let's get the distance to like 0.1 and strength to 0.12. And now this is looking a lot better, but the problem is it's very sharp. So I like to use the math node here. Usually, as you have seen, I really like to use math anyways. And I'm going to use the smooth maximum node. Now, smooth maximum, what does it do? Well, it does basically so. So currently we have a thing like that. Smooth maximum takes, okay, I'm going to basically cut things off at threshold you told me. Like that, smooth maximum or smooth minimum from down here. But what makes it nice is that you can actually control the smoothness like that, you know, with those values that you have there in the control distance, right? So I'm gonna put the distance to 0, and now this acts basically just as greater than or less than. And as you see, I can like cut away the bottoms of this thing. Let me actually see this. So what I would like to see, because you know the wrinkles on somebody's forehead look pretty much like that, you know. So they have like smooth tops, but they have like pretty sharp bottoms, if this was said correctly, or like the I don't know what the word for this is. And this means that the bottom is the black area. So I would like the black area to remain sharp. Let me see how this looks. So the black area currently is getting smooth out if I use this node, right? So I don't want this. So I should switch this to smooth minimum. And this basically gets the tops a bit more like smooth out. And I'm gonna use like a smoothness like that, or maybe even more. Let's see how this looks right now. So this is looking pretty okay, but I just think we should maybe decrease this a little bit more and add some more smoothness to it. Something like that, you know. So this was before, really, really sharp, and this is after, like considerably smoother. And now what we can do is actually use some noise here. So I'm gonna add some distortion. Looks more like somebody's like wrinkled forehead. And maybe detail scale, not too much. Maybe like that. Maybe some more detail. Something like that. Doesn't matter too much. This is not a nice wrinkle map anyways. I'm just gonna make something that works, you know. And I'm gonna use this Z value here as the strength. But remember, our strength was 0.1, so probably this one here is a bit too strong right now. So this is, I mean, this is like that. And now if I move this, I'm gonna disable the overlays. Now if I move this, I mean, I got some things here, right? But this is way too strong. So I'm gonna use a math node because, as you remember, our gradient goes from 0 to 1, but we only need the strength of 0.1. So we should like multiply this with at least like 0.2 or something, which is too much still, but maybe it works better. So I'm gonna put here 0.2 and let's try moving this heads. And as you see, now we have some wrinkles appearing here. Look at that. And this doesn't look too good maybe. I mean, it looks okay, but the problem is it's like a bit too sharp. Too sharp of a thing here, right? So I'm actually gonna go back to geometry nodes, and how can I make this smoother? Because you might occasionally want to do this. So I'm gonna switch this to B-spline actually, and I'm gonna add some more dark things here in the middle, basically, like that, and I'm gonna add also a third one. I'm gonna basically make the darker area in the center here a bit more like controlled, so I'm gonna put like 0.3, and then for this one maybe 0.7, so something like that. So I mean the blue gets more gradually into black, and otherwise vice versa. And I'm gonna copy this node here. I'm gonna go to the base head, back to the base head, real head, base head. I'm gonna paste this new ramp here. I'm gonna use this one here because they have to be in sync on both of the meshes, right? So now let's see how this works. So if I select this head, I'm gonna go to edit mode. Again, disable the overlays, select like a random thing here, and I'm gonna move this. Well, I think this is a bit of a better thing happening right now. Maybe this is a bit too weak even. So I'm gonna go back to shaders and put this like 0.35. And let's try this again. I think it's okay actually. I mean, you can give some pretty, it actually looks pretty nice, I think. You can do something like that. This one looks really sad. Let's try to do something with the eyes as well. So, I mean, of course, it's not the wrinkle map for the whole head, but it actually works pretty nicely, right? As you see. I mean, this looks this looks really stupid, but it actually works. Let's try to make the other one angry, or can we? Actually, it would be nice. I mean, if you have like a real face, like Chris Jones has, with real rigging and stuff, then of course you have bones. You can revert the changes and stuff, and you have like many. You have more variation in this wrinkle map. unlike we currently have only one texture, and even this actually works, I mean, pretty nicely, I have to say. So this is like an alien, you know. Okay, anyways, this is working like that, so I'm gonna disable this bump for a moment so that we can see the difference. I mean, and you can change, of course, the strength and stuff, and use this also not as only bump, but actually as displacement. So just as this scale here, and displacement goes to here. But I think you already know that, and I'm actually not like a very good character artist, so I let this area of actually making believable humans to other people. But I think this system will help you quite a lot. So if you have questions, if you have anything, let me know. The project file is on Patreon. And yeah, see you next time. So I hope you enjoyed that.